chapter 4. So today we're going to start with chapter 5. All right. Am I sharing my screen? Not yet. All right. Can you all see my screen?
Yes.
Yeah.
Excellent. Okay, so far we have discussed how objects move. So we looked at our equations of motion: v equals u plus at, v squared equals u squared plus 2as, s equals ut plus half at squared. We look at objects going in 1 dimension, 2 dimensions, vectors, all sorts of things. But we never discussed, okay, why do they obey these equations? Okay, we know it's v equals u plus at, but why is it v equals u plus at? What is special about it? Okay, how did we end up at v equals u plus at? Why does it speed up? Why does it slow down? We never answered any of these questions per se. Okay, so today we are going to start the dynamics portion of our course, which answers the question of why do things happen the way they do. Now, here we have a ball. It starts moving, accelerates, and then decelerates, and then stops. Very simple issue. It had an initial velocity, a final velocity, and we know how to find the initial and final velocities and the positions using our equations. The question is, why is it accelerating or decelerating? And the answer is what we call force. Okay. Now, what is the force itself is a more complicated issue. At the very, very simple, we can say it's a push or a pull. And if we want to go to, particle physics or quantum mechanics or something as complicated, we can define them as the exchange of virtual particles or gluons or whatever. Really complicated. But the effect, no matter what description we want to give it, is still the same. So let's stick to the very simplest of descriptions and build up from there. Now, force is a vector. So the direction of the force is very, very important. If we have this box and we have these two people and they're pushing it from opposite directions, what's going to happen to the box?
Doesn't move.
Okay, doesn't move. Does it always not move?
No.
No.
If the force is
When
equal, it
equal,
must
it
move.
doesn't move. Depends
Okay,
on
so that's a more accurate descriptions. Depending on how much each person is pushing, it may or may not move in one of the directions. Yeah. Now, if they're both pushing with the exact same amount, okay, then it will not move. If they are pushing with different amounts, though, it will move in one direction or the other. And that, we say, is the principle of superposition of forces. That is, we look at the net force, the sum of all forces. Okay, we take the vector sum of all the forces on an object to see how is it going to react. Now, if I have something with F1, F2, F3, I can either add it with the head to tail method or using components, okay, and find out what is the resultant force. Now, objects tend to be at rest. Objects will be at rest until a net force acts on it. Okay, so as long as the net force is 0, notice that I'm not saying force is 0, I'm saying net force is 0. Okay, nothing will happen. But if we have an excess force, wow, that is one strong lady. Okay, as long as there is a force on it, there will be a movement. Okay, Do not piss this lady off. You do not want to be on the wrong side of this lady. Okay. So, we come to Newton's first law of motion. والذي يعرف ب يعرف عندي, this is not the formal name, بقانون التنابلة. حد يعرف تنبل؟
No.
تنبل مصطلح عامي وليس مصطلح فصحى فصيح. التنبل مصطلح فصيح ايضا اتوقع. التنبل ما ادري والله. انزين. التنبل في اللغة هو الشخص الكسول الثقيل الذي لا يحب الحركة ولا يحب العمل. الكسول.
One who loves sofa surfing.
طيب انزين. So تعرف صار لي فضول الحين. Let's see. تنبل التلميذ كسل وبلد. تنبل الجمع تنابل وتنابيل، والتنبل هو الكسلان الخامل بليد تلميذ تنبل. تنابلة السلطان تقال للكسالى المتبطلين من الناس. اوكي، طلعت كلمة فصيحة وليست كلمة عامية. New information of the day. زين. See, we always learn new things. Okay, so I know this as
Inertia.
قانون التنابلة. What does this mean? The formal formulation of Newton's first law of motion is every object continues its state of rest or of uniform velocity in a straight line as long as no net force acts on it. طويل عريض. What does it mean? It means أنه every object in the universe تنبل. Okay? We like objects like things to be as they are. They don't like to move. They don't like to change. Unless you force them بالغصب انك تحركهم او تخليهم يتغيروا, they will continue how they are. If it's not moving, if it's in a state of rest, it will not move. If it's already moving, it will not stop or slow down or speed up. It will stay as it is. If it's in a straight line, it will continue in a straight line, okay? Unless a net force, okay, acts on it to change that thing, okay? This is why I call it قانون التنابلة, because unless you force them to do something, they're not going to do something. And this is the case of everything in the universe. ما تجون بعدين ما تذاكرون تقولون انه الدكتور قال كل شيء في اليونيفرس تنبل. This doesn't apply to education. Okay. Let's take a quick look at this question. Which of the following statements can be explained by Newton's first law? So Moodle is having a few issues. I have not been able to upload the questions so far. Okay, so we'll do this using Google Polls. Okay, or just the chat screen. Which of the following statements can be explained by Newton's first law? A, when your car suddenly comes to a stop, you move forward. B, when your car rapidly accelerates, you are pressed backwards against the seat. Neither A nor B, both A and B, A but not B, and B but not A.
Both A and B.
Both A and B, okay. Does anyone disagree?
Both.
Any other points of view? No? Okay. All right. A and B is correct. Because what did we say? If it's moving, it's not going to stop moving. If it's stopping, it's not going to stop. So when your car suddenly comes to a stop, you keep moving forward. That is correct. You haven't stopped. The car has stopped. You will continue moving forward. When your car rapidly accelerates, you are pressed backwards against the seat. Yes, because it's the car that's accelerating, not you. So you are staying where you are. The reason you are pushed back against the seat, and we will discuss this a little bit later, okay, is not because you are pushed back against the seat, is because you are tumble and you're not moving and the car is already moving. So you're getting stuck to the back of the seat لأنه السيارة ما تنتظرك and it's already moved. And it hits you on your back. اوكي هذا كيف ما بالعربي لما واحد يعصب يقول لك اطلع من الغرفه ولا اطلع من البيت ولا تخلي الباب يضربك وانت طالع. It's the same thing. اذا انت وقفت على الباب والباب تسكر بيضربك. Okay, you are not moving, the car is moving, so it will hit you in your back and you will feel it as if you are being pushed back around at the seat. So we have a name for this, the tendency of an object to maintain its state of rest or uniform motion in a straight line. I call it التنابلة. Physics calls it inertia. Okay, and it's defined as the resistance to change in the state of motion. Okay, what is the example of inertia? Because of inertia, say you are in a car, you're driving at 80 kilometers per hour. السيارة تدعم لا سمح الله في جدار. The force from the wall is on what?
On the car.
The force is on the car, right? So the wall exerts a very large force on the car, stopping the car immediately from 80 to 0 kilometers per hour. What is the force on you?
The same?
Are there any forces on you?
No.
Did you hit the
No.
wall? Did the wall hit you?
No.
Nothing.
No.
Nothing happened to you, صح؟ أنت داخل السيارة أو أنت داخل السيارة، السيارة تتحرك بسرعة 80 وأنت أو أنت جالسين فيها وتتحركوا مع السيارة على سرعة 80. طيب السيارة دعمت الجدار وقفت على 80 لكن أنت أو أنت ماشي يدعموك. Which means, according to Newton's first law, you are going to continue going at 80 kilometers per hour, which is a problem because the car is now no longer moving, which means you are going to fly out of the front windshield like this guy in the clip and fly out of the car. And I know this sounds like something, you know, from movies, but I actually do know personally a friend of mine who this happened to. كان يوم الخميس، كان مستعجل راجع البلد من مسقط وكان يسوق على 120 130 ودعمته شاحنة وما كان لابس حزام. So what happened? The car stopped.
He
He didn't.
floated.
He
Hit
flew
the glass.
He flew through the glass, not into the glass. He flew through the glass. لأنه كان يسوق واجد بسرعة 130 140 فهي ضرب الزجاج والزجاج اتكسر وطار من الزجاج ولقوه على بعد 60 70 متر من السيارة. حرفيا طار في الهواء نفس الكليب هذا ولقوه 60 70 متر من السيارة. طبعا كان فاقد الوعي وكان في غيبوبة لمدة 9 أشهر تقريبا 9 أشهر 10 أشهر كان في غيبوبة. الله نجاه بأعجوبة وقام بالسلامة بعد 10 أشهر من هذا الغيبوبة. So, yeah. Moral of the story is Newton's first law is a pain, so please wear seatbelts. Okay, and I have lost another friend. الله يرحمه نذكره بالخير. كان عندي صاحبي كان اسمه محمد مكي، كنا نسميه ام. كانت أيام الإعدادية، وكان طالع على كان طالع على بقي رايحين في الرمال، وهم في الشارع دخلت عليه سيارة ودعمته. Of course buggies don't have seat belts. He flew about 150 meters head first, and unlike my other friend who was lucky, Muhammad was not lucky. We lost him at a very, very young age. He was a very smiling person, a very happy person. So, yeah, physics laws don't know. ما عندهم مزاح. Physics is a pain. Anyway, keeping this in mind, okay, keeping this in mind, okay, let's look at this question. A pipe is bent into the shape shown and is sitting horizontally on a tabletop. You are looking at the pipe from above. A ball is shot into one end and exits the other end. Which one of the paths shown will the ball follow when it leaves the pipe?
2.
Okay, we have a 2, we have a few 3s in the chat, we have a 5, we have a 3, we have 2, 2, 3, 2, 3, 5, 3, 3. Let's give it a minute and see how many we get. 2, 3s. Someone wrote 6. We don't have 6 options. Okay, so we seem to have a plethora of answers. Okay. Now, remember, this is sitting horizontally on a tabletop. Okay. Now, since it's horizontal, what are our forces in the horizontal? So the ball will come like this, and then it will come out like this. Now, what are the forces in the horizontal?
None.
We have no forces, right? Even if we say friction or something like that, it will be in the opposite direction. But we haven't covered friction yet. So far, we don't have any. Gravity is in the y-axis, not in the x-axis. And what did we say happens with the x and y axes?
They are separate.
قلنا they are separate وزعلانين من بعضهم البعض. One doesn't affect the other. So since gravity is on the y-axis and this everything in this photo is on the x-axis, gravity doesn't actually affect anything. Now, according to Newton's first law, things that are moving, unless they have a force on them, they will continue the way they are. And here we have no forces. So which way is it going to go? It's going to go in a straight line with number 3. Right? There are no forces to make it go to the left or to the right. So it will just continue going straight. Okay, what if I said it was vertical? What if I said it was vertical? Which one would it be then?
2, I guess.
2, 1. Okay, so we seem to be between 1 and 2. So no one believes 3, no one believes 4, no one believes 5. It's not going to float for no reason. But that leaves us between 1 and 2. Now, the ball is coming out like this, and my gravity, which means its velocity, it has a Vx, and a Vy, صح?
Yeah.
Now gravity is going to affect the Vy, it's going to increase Vy. But what is it going to do to Vx?
Nothing.
Nothing, right? It's just like when we did the projectile motion, like this. The x-axis is, the x velocity is constant. Yeah. So if my x is constant and not 0, the ball will continue moving to the right until it stops. So the correct answer is this one, number 2. It's this last part. Okay? It will go in a curve until it hits the ground. Number 1 is only possible if we are releasing it from rest. So the whole velocity is in the y-axis, it just drops down. Okay. Any questions on what we did so far?
No.
No.
Okay. We spoke about frames of reference when we're looking at relative motion in 4.6. And we said there are sometimes frames of reference that are accelerating and some that are not accelerating. Today we are going to classify them into 2 different types based on a different aspects. We have inertial frames of reference and we have non-inertial frames of reference. What's the difference between these 2? The difference between these 2 is Newton's first law. If Newton's first law is valid in that frame of reference, we call it an inertial frame. If Newton's laws are not valid, we call it a non-inertial frame. Okay. Is the idea of inertial and non-inertial clear?
Yes.
Okay, let me show you something. كالعادة أنا ملان وما عندي لا شغلة ولا مشغلة. آخذ كوب الشاي مالي وأشربه برا في الفضاء الخارجي because you know I am bored. What I do is I take a ball or a disc and I throw it from the top of. يا أخي أنا أحب أشرب واجد شاي، الكوب صغير واجد. زين. I release the disc from the top of Earth. What's going to happen to it? Can anyone tell me?
Will keep flying.
So keep flying around Earth.
Okay. This is what I'm going to see. I am going to see it go from the top to the bottom in a straight line. Gravity pulls it downwards, right? طار الشاي من الكوب كله بسبب حمود. ضربها عين. رجعت الكرة الأرضية. سويت لي كوب كان ساخن واجد فقررت إني أروح القطب الشمالي عشان يبرد بسرعة.
It will freeze.
And I decide to do the same experiment again. I'm sitting, and this is what I expect to see. كيف ما when I released the disc وشفته من برا, it was going in a straight line. I expect it to go in a straight line. I release it, and this is what I see. راح على زاوية. رجعت برا. it's in a straight line. رجعت داخل, it's not in a straight line. طيب ايش هذا ليش جالس يروح على جنب؟ ايش السبب؟
Earth is moving.
Earth is moving, right? And Earth is moving in what direction? How is Earth moving? How is Earth moving? In what way?
وهي استوت على الجهة الثانية، حركة الأرض على الجهة الأخرى.
هي كرة، الكرة الأرضية هي كرة صح؟ And it's moving in a circular motion, which means its velocity is always changing because it's rotating. Velocity is always changing, the direction is always changing, which means it is accelerating. Okay. معاي دلة كبيرة سليمان، كل شوية عبي الكوب. So over long distances, the ground is a non-inertial frame. Okay, which means that Newton's first law, that I'm going to go in a straight line and unless there is a force on me, has a problem, because here I have no forces acting. صح? My force is only in the y-axis, downwards. But this thing is moving to the left in the x-axis. الحين أنا عندي مشكلة. Newton's first law يقول unless there is a force, there should be no movement. والexperiment يقول لي there is no force, but there is movement to the left. الحين من فيني كذاب؟ الexperiment ولا نيوتن؟
أكيد نيوتن.
Newton cannot be applied every time.
Yes. Newton cannot be applied in non-inertial frames. Remember, this is what we said in this slide, صح? Non-inertial frames, Newton's laws are not valid. We need to fix them. Okay? So we need to fix them by adding a fictitious, non-real force. Remember when we were dealing with circular motion, we said we have centripetal acceleration or centripetal force always towards the center?
Yes.
Okay. Okay, سؤال. لما كنتوا صغار وانا سويت هذا الشيء، ما اعرف اذا انتم سويتوها او لا. طيب حطينا ماي في كوب او في دله او شيء وقمنا نلفه فوق راسنا. What happened to the water?
Stay in its place.
اذا هذه الدله الماي كان يلصق على هذا الصوب صح؟ على برا.
Yes.
Yes.
But we just said انه السنتريبيتال force is to the center. فالمفروض ان الماء يطلع من الدله، ما مفروض انه يلصق في الدله. Now I will write three things. Centripetal, centrifugal, Coriolis. Okay. Remember when I told you this is called centripetal, not centrifugal, not Coriolis? This is the reason. The centripetal force is an actual force. Okay. It has a medium. It's caused by the rope or the tension or something. The centrifugal or the Coriolis force, these two are the same thing, by the way, just different names, okay, are not a real force. What happens is, because the Earth is rotating, because the Earth is an accelerating frame of reference, normal Newton's laws do not apply. We need to fix it, okay, by adding this centrifugal or Coriolis force to make the physics work again. This is why we call it a fictitious force. Okay. In reality, okay, what is happening? In reality, your water is there. It's not going anywhere. It's the Earth that is moving and pushing against it. It's just like when the car is pushing you on your back when you accelerate. Okay, there is no actual force on you. It's only that you are standing there still and the car is already moving فشلك وياه. زين؟ لما سيارة تتحرك نفر من يشيل الأول؟ سيارة من قال له؟ نفر من قال له؟ Okay, so see who says physics cannot be fun. Okay, all right, good, I'm happy. If I make you love physics, I'm doing my job well. لا شوف شاي مالي أنا، ما نعطي هذاك الأستاذ شاي، هذا خليه يسوي له شاي بنفسه. شاي مالي أنا. شاي is not a joke. شاي is mine. رحت الفضاء الخارجي حال الشاي آخر شيء أعطيه. Okay. All right. Mass. First, قبل ما نبدأ mass. Any questions on what we've done so far?
No.
Okay.
لا دكتور.
All right. We come to mass. زين. عندي سؤال. This is an elephant. Its mass is large. This is a mouse. Its mass is small. Good. طيب حد يجاوبني ايش يعني mass is large و mass is small؟ ايش يعني mass؟ جاوبوني حتى بالعربي ما لازم بالانجليزي.
الكتلة.
انزين ايش يعني الكتلة؟
مقدار المادة في الشيء.
الوزن ضربة الجاذبية.
الوزن ضرب الجاذبية is weight not mass. انزين اوكي، خلينا ناخذ مثال. احمد الرحبي كتب مثلا مادة تشغل حيز. اذا انا اسالك ايش الفوليوم مال الاليفنت، ايش الفوليوم مال الفيل، انزين سهل، طول في عرض في ارتفاع، انزين وله physical meaning صحيح. This is literally حجم المساحة، حجم البتاع اللي ياخذه الفيل، انزين. لكن لما اقول mass quantity of matter، كتلة، حجم الشيء، طيب ايش؟ انا بعدني ما حصلت الجواب كيف ما حصلته في الفوليوم.
It's the amount of matter in an object.
Okay, amount of matter in an object. Okay.
هي عبارة عن مقاومة. المقاومة.
Okay, we said it's amount of matter in an object صحيح. What is matter?
Thing.
It's things صح. So let me tell you something. الحين عندنا الفيل. الفيل مكون من ذرات atoms صحيح. Does the elephant have a mass?
Yes.
Because it's made of stuff. صح?
Yes.
Okay. The stuff are called atoms. Do atoms have a mass?
Yes.
Yes.
Okay. إذا ما حلينا السؤال. We just pass the buck. طيب, what are the atoms made of? Protons, neutrons, electrons. جميل جدا. Do these things have mass?
Yes, of course.
Yes. إذا حلينا مرة ثانية ما حلينا السؤال، مجرد شتنا على قدام. إنزين. نجي ناخذ واحد بروتون. Does it have mass? Yes.
Yes.
So it's made of things. طيب ندخل على داخل نشوف الكوركس. Does it have mass? Yes. اوكي اذا نحن ما جالسين نجاوب على السؤال الاصلي صح؟ انزين نحن بس جالسين نأجل المشكله، كل ما سالنا شيء نعقه على قدام، نروح على قدام نعقه على قدام اكثر، نعقه على قدام بعد نروح قدام اكثر، جالسين الهروب الى الامام. انزين لكن نحن بعدنا ما جاوبنا السؤال. طيب لما نحن نقول it's quantity of matter, what is it?
It could resist velocity and like inertia.
Excellent. We're getting somewhere now.
Can be affected by force.
Okay. Can be affected by force. We come to Newton's second law. F equals ma. Okay. Force measured in newtons, mass measured in kilogram. Okay. We can write it in component forms in the x-axis wahdo, in the y-axis wahdo, in the z-axis wahdo, because we can write a, x, and velocity, acceleration, and distance all in 3-dimension vectors. This is fine. But let's go back to our initial question. What is it that mass is? Okay. And the best way we can define it, at this point at least in our studies, is that mass equals force divided by acceleration. Now I know في بعضكم لو كنا في lecture theater كان probably بيفعني بشيء، يقول لي صدعت لنا راسنا 10 دقائق وآخر شيء you're just rearranging an equation. Okay. يعني صدعت لنا راسنا وآخر شيء you're just rearranging an equation. Mass equals force over acceleration. But this actually has a meaning. Let me do one thing, وبعدين you will see what the meaning is. If I have a force of 1 Newton and it accelerates by 1 meter per second square, I will have this will be equal to a mass of 1 kilogram. So our definition of mass is how much acceleration do I get from a certain amount of force. Okay, say I am pushing with a force of 100 newtons. Okay, إذا دفرت تفاحة ب 100 نيوتنز إيش بيصير فيها؟ بتطير، صح؟ انزين لو دفرت سيارة ب 100 نيوتنز إيش بيصير فيها؟
It may not move.
ولا عندها خبر. يا جبل ما يهزك ريح. صح؟
Maybe.
Yeah. So the 100 newtons causes a much bigger acceleration, okay, with an apple, giving it a very small mass. So the amount of resistance to motion is less. Okay. At this point, this is the best way we can, okay, define what mass is. Now, out of interest, before I go to the next slide, because, you know, let's see what's the definition of mass on Wikipedia. Mass is both a property of a physical body and a measure of its resistance to acceleration, a change in its state of motion, when a net force is applied. An object's mass also determines the strength of its gravitational attraction to other bodies. Okay, so we have an interesting concept of mass here. And remember in chapter 1 when we're talking about, you know, when we were talking in chapter 1 about the definition of the kilogram, we said it has been recently redefined. If you're interested about these things, you can speak to me or you can just go to Wikipedia, as you can see. there are some very interesting things like, you know, gravitational mass, inertial mass, quantum, okay, how they are related to each other. It's a very, very interesting concept. Okay. It also has, the Wikipedia article has an interesting introduction on pre-Newtonian concepts. So before we actually before we introduce, before Newton, before we knew it was, you know, resistance to motion, or how much the force causes how much acceleration, weight was an amount. In terms of الفراعنة وما قبل الفراعنة, it's some interesting stuff. Okay. If anyone aside from this section opens this lecture on YouTube, they would have a very fun time seeing us define تنبل وتنابلة I would like to see their face when they open this. Okay. If the net force on a body is 0, its acceleration is also 0. Oops. Its acceleration is also 0. Right? We agreed on this. The forces and body are said to be in equilibrium. But this is very important. There may still be forces. Okay? Just because this box is not moving does not mean force is equal to 0. We have two options. Box does not move. Option 1, the force is equal to 0. There's no force on it. But we have option 2, the sum of forces is equal to 0. And these are very, very different. In the first one, there is no force. In the second line, okay, the sum of all forces is equal to 0. So it might be that this person is pushing with 100 newtons in this direction, and this person is pushing with 100 newtons in this direction. Since force is a vector, 100 plus minus 100, because it's in the opposite direction, is 0 newtons. And this is why our net force is equal to 0 and there's no acceleration. Okay, this is very, very important. And we will be using the concept of net force over and over again in the upcoming sections and chapters. Your book has a good sample problem, 5.07, acceleration of block pushing on block. And a few of you actually indicated in the reading quiz that actually there was no reading quiz yesterday. Okay, because we had Moodle problems. But usually I know students have some issues with this, so I included it anyway.
Mister, so how
Mr.
about
what about
We will have it inshallah today at 7:30. If we are still facing problems with Moodle, I will send you an email beforehand telling you it's cancelled. But for the time being, assume it's still there.
Okay, can you just, when there is a quiz, can you put an announcement in Moodle?
There is always, we have a work plan in Moodle.
Yeah.
If you look
Yeah.
at the work plan, it indicates in which weeks we have a quiz.
Yes, I know, but like the exact time and everything.
It's always the same time, 7:30 on a Wednesday, on the weeks indicated in the work plan. There's no change.
Okay.
Okay, so it's easier for you as students as well to timetable your, you know, your timings.
Okay, thank you.
Okay. Okay, where is 5.03? Why am I unable to find it? 5.01. 5 point. Wait, what? Where did it go? Not this. 5.07. Here we go. Let me close this first because it keeps popping up. Okay. A constant horizontal force. So in the book, it is in sample problem 5.07 with numbers. But to start with, we'll just look at the idea. Okay. A constant horizontal force, F applied, is applied to block A of mass MA, which pushes against block B of mass MB. The blocks slide over a frictionless surface, as shown. So we're not looking at friction at the moment. A, what is the acceleration of the blocks?
The same.
Is it F applied over MA, F applied over MB, or F applied divided by the sum of MA and MB? So, شكلكم رحتوا بحر. Which one is it? Do we divide the force by MA or by MB or by the sum of MA and MB?
The last one, maybe?
Okay. Last one, last one. We have 3 people so far who said last one. 4 people. Indeed, it is the last one because these blocks are tied together, right? Since they are tied together, the force ينطبق على اثنيناتهم. It applies to both of them together. So F applied is equal F acceleration is equal to F applied divided by the sum of both masses. Okay, what is the force on block B from block A? Because see, our applied force is on block A aslan, not on block B. So what is the force on block B from block A? Is it going to be what we know in general that force equals MA? But is it F application, MBA, MAA, or the sum of the masses multiplied by A? I'll give you a minute to think.
The sum of the masses.
Sorry?
The sum of the masses multiplied by.
Sum of the masses, okay. Okay, Layal says second. Mariam says third. First. Last. Okay, so we have pretty much an even distribution between option 1, 2, 3, and 4, and that is expected. Okay, we don't have the polling PIQ today because unfortunately I couldn't post them to Moodle properly. Okay, but we seem to have an even distribution from the two. Okay, now here's the key point here. The force applied on block B, okay, is directly proportional to the acceleration of block B, right? Now we agreed that the acceleration here is F applied over MA plus MB. So my force for block B will be mb multiplied by the full acceleration. Okay. Now the full acceleration we have already decided is F applied divided by MA plus MB. So my total will be MB F applied times divided by MA plus MB. Is this clear or is there confusion?
repeat دكتور.
Okay. Are we all okay with part A? What is the acceleration of the blocks?
Yes.
حد عنده مشكلة مع part A؟ Okay. Part B. What is the force on block B? Force is F equals MA, صحيح? We agree on this. لأن هنا عندنا إشكالية أنه force equals MA from Newton's second law of motion.
نعم.
Okay. بما أنه الفورس على بلوك بي إذا لازم يكون مع الماس مال بي. صحيح؟
Yes.
Okay. Then we simply multiply it with the acceleration. The acceleration here is the acceleration of the total system. Okay, إيش هو هذا الأكسلريشن؟ كيف أعرفه؟ حسبناه في part A.
Victor, can you repeat part A?
Okay. Part A, we have an applied force that results in some acceleration. Okay. We want to know what is this acceleration. Now, since this force is being applied here at the outset, okay, and these two blocks are together, you can think of them as a single big block. اوكي لانك انت لما تدفع بلوك A راح يدفع بلوك B فاثنيناتهم راح يتحركوا بنفس السرعه. طيب مثل قطار. So you look at the total mass MA plus MB. فكر فيها كذاك. عندك يوكازونا، عندك نحوف مسكين، تو هم واقفين جنب بعض. زين انت تدفر النحيفون مسكين. طيب يوم انت تدفر النحيف راح يدفر ال200، لكن كم هم يتحركوا ما ينحسب فقط بانك انت كم تدفع النحيف، لانه النحيف والمتين is a single system، فايضا كم النحيف يقدر يمشي المتين. or هذا الفلوس دائما تنفع. examples of money are always good. okay عندك 100 ريال. you want to divide them. okay now you're dividing them on the entire system. So this guy will get 20 مثلا or this guy will get 80. فلما يسألك يقول لك كل واحد كم بيحصل، تقول طيب أنا عندي 100 ريال وأنا راح أقسمها على مجموع الأشخاص الموجودين. وضحت الفكرة؟
Yes, doctor. Thank you.
Let's look at a question similar to the one we did before. The drawing shows a steel ball flying at constant velocity from point A to point B. There is no gravity. Okay? There is no gravity. As the ball flies past point B for a very short time, a magnet exerts a force on it in the direction of the magnet. Which of the following trajectories does the ball follow beyond point B? Okay. Can we do a poll here? Let's see. PIQ 2. Option 1 is 1, 2, 3, 4, 5. There we go. Let's see if we can do this. You should get a notification and know there is a poll. There we go. Let's give it a minute or two. Let everyone answer in Google Meet. So on the mobile phone, there's no way to take part. Twenty, 25. Only 27 people have responded. لماذا هكذا؟
دكتور أنا فاتح من التلفون ما ظهر معي.
ما يظهر في التلفون. This is why we're using Moodle بالعادة لأنه في جوجل ميت ما ينفع بالتلفون.
PIQ دكتور ما تبني.
لا مش PIQ هنا في الجوجل ميت في البولز. Okay, let's see. We have most people have chosen option 1. A few people have chosen option 2, and a handful of people have chosen 3, 4, and 5. Okay. Well, first things first, we said there is no gravity. So there are no forces pulling it downwards, right? Second thing, we said steel ball, and there is a magnet here. So the force is going to be up. The magnet will pull the steel ball, right?
Yes.
So option 5 and 4 and 3 are already out of the question because it will be pulled up. Now the only question is 1 or 2. Okay. Now the key point here is set. It's set for a very short time. Okay. Very short time معناته أنه الكرة خطفت من هنا واجد بسرعة. إذا خطفت الكرة واجد بسرعة، إيش معناته هذا بالنسبة الوقت اللي كانت موجودة فيه تحت تأثير القوة بالضبط؟
بسيط
جدا بسيط. معناته القوة اللي تعرضت له كانت في فترة بسيطة جدا، فيا دوبك رقم 2 شوية ارتفع. إذا كان إذا ما قلنا for a very short amount of time، بعدين ممكن نعمل رقم 1. طيب انزين. Let's talk about what a system is. Say الحين I have this cart thingy. It consists of 2 brown pieces and 1 black piece in the middle, and it has 5 tires on one side and طبعا 5 tires on the other side. When I apply any physics problems on it, how do I deal with it? Do I treat each square on its own? No, that would be too complicated. What we do is we define all 3 things together as what we call a system. Okay? And we deal with it as one body. Now, any force exerted on this system by forces from outside the system, from outside the circle, from outside this combination, we call it an external force. Any force on the bodies exerted by bodies inside the system. So for example, this thing, the brown one, has a force on the black one. The black one has another force on the brown one. That's لهذا السبب هم يجرون بعضهم البعض صحيح؟ كل هذا الانترنال فورسز، كل هذه الفورسز الداخلية نسميهم internal forces inside the system. This is very important. Only forces that act on an object determine its motion. And we look at only the forces that act on the object itself. So we have an apple, and we have these arrows. What is this type of diagram called? It's called a free body diagram, and we use it over and over again. Now, إذا أنتم مثل حالاتي فنانين في الرسم, you can draw it this way. إذا أنتم مثل حالات ناس ثانيين, بعض الناس غيرنا اللي متواضعين في مجالهم في الرسم, drawing an apple might be a little bit difficult. So we just draw a dot. بعدين مراعاة لمشاعر الناس اللي they are drawingly challenged, نحن دائما نحط dot علشان we don't make them feel bad, يعني أنه their drawing is not as awesome as ours. So we do a free body diagram for any problem, and we draw all the forces on it to make it easy for us to look at the forces. Okay. Now I go back to this for a second to make it very important distinction. Okay. When I look at this system, نحن قلنا this is the system, صح? These forces do not cause an acceleration. They are internal forces. Have you ever tried sitting inside a car and making it move by moving your body? ما لازم سيارة كبيرة, سيارة أطفال, سيارة لعبة. جالس داخل السيارة وجالس تحاول تحركها, ينفع؟
Yes.
بأنك تحرك جسمك؟
Yes.
إنزين. It doesn't work. تقدر تشرح لي كيف خليت السيارة تتحرك؟
I mean, when you're in a bus, you can just push side to side, right?
Okay, you're a bus, you push side to side, وبعدين?
If there is enough people, it will move, it will shake.
It will shake, yes, maybe, but that is because your collective force is outside the center of motion. We will describe this more in chapter 10. But think of it this way. هذا السيارة هذه الصغيرة مال الأطفال اللي كذاك, هذه مال الأطفال زي اللي عمرهم 2-3 سنوات يلعبوا فيها في البيت.
Okay.
حاول تخلي الطفل جالس عليها, إنزين, ويحرك السيارة بدون ما رجوله تجي على الأرض. ينفع؟
No.
ما ينفع. إذا يحتاج يطلعها في طريقة اللي هي نفس الشيء لما نسويها في المرجوحة. نحرك جسمنا وراء وقدام, وراء وقدام, صح؟
صح.
إنزين. لكن لو أنت لاحظت شيء في المرجوحة, إذا قلنا هذه هي المرجوحة, طيب لما نحن نجي نمرجح, إيش نسوي عشان نتمرجح؟ يوم نروح ورا راسنا يوصل لين هنا تقريبا، صح؟ او جسمنا يوصل لين هنا خارج اطار المرجوحه نفسها. ولما نروح قدام ايضا what happened؟ لما نروح قدام عشان نحرك المرجوحه ورا نفس الشيء، يكون جسمنا خارج اطار المرجوحه نفسها، صح؟
صح.
This is the reason. طالما نحن داخل اطار المرجوحه we are considered internal forces، ما نقدر نحرك. لما نطلع جسمنا خارج الاطار نتحول الى external force، فنقدر نحركها. زين، هذا رضيع شكله ما طفل. Okay, so last thing before we end today, this is actually quite a long lecture. Okay, Newton's third law of motion. قبل ما نشوف التعريف الرسمي، أو خلينا نشوف التعريف الرسمي. Whenever one object exerts a force on a second object, the second exerts an equal force or in the opposite direction or in the first. أو for every action there is an equal and opposite reaction. You know this from school. Yeah. The formal definition is when two bodies interact, the forces on the bodies from each other are always equal in magnitude and opposite in direction. I like to think of it in a different way. It makes it more fun. من فينا ما تضارب في المدرسة؟ دائما نتضارب، ودائما لساننا طويل، وبعدين يوم يجي وقت الضرابة، انزين، يوم يجي وقت الضرابة، او حتى لو ما في المدرسة، مع الاخوان، مع اولاد العم، اولاد الخال، مع الجيران، انزين، طيب نجي، انزين، على فكرة حتى اللي شو اسمه هذا، خصوصا اللي يشرد، انزين، خصوصا اللي يشرد او الطيب اللي ما يريد يتضارب، يجي له واحد يقول له بضربك، انت هو يبغى يشرد من السالفه، ما يبغى يتضارب، ايش يقول؟ جمله مشهوره، هذه اشهر جمله موجوده في حوش المدرسه.
عند الباصات.
هذه عاد خلاص تتضاربوا بعدين، بعد ما وصلت عند الباصات انت تبغى تشرد تو، انزين، تقول له تضربني بضربك. someone already said it in the chat. شامس، انزين، تضربني بضربك. خلاص انت عاد واصل مرحله الضرابه، you want to get out of it، انزين، تضربني بضربك. okay, this is a very famous line. انزين، انزين، ما شاء الله الجمل كلها جالسه تطلع واحده واحده.
محترفين.
زين، طبعا الضرابه بكبرها ما تطول اكثر من 30 ثانيه، هم بوكسين، ما اكثر عن بوكسين، لكن نص ساعه قبلها تضربني بضربك، تعال كنت رجال، سوي لا سوي، بجيب ربعي، بجيب الشله، هذه نص ساعه، اخر شيء السالفه كلها بوكسين وخلصت السالفه طبعا. زين، but let's focus on تضربني بضربك. There are two main rules. إذا أنت ضربتني أنا بضربك، إذا أنت ما ضربتني أنا ما بضربك. We need contact، صح؟ The two objects need to contact each other. لازم يكون في تلامس ما بين الطرفين. بالتالي إذا ضربتني، إذا لمسني، أنا بضربك. That is the first rule. إنزين؟ The second rule ما تضربني بضربك إيش؟ كل ما ضربته كانت اقوى انت ضربتك بتكون اقوى. هو عوراك، انت تبغى تعوره اكثر، انزين، انت تبغى تعوره مثل ما هو عوراك، انزين. وطبعا القانون اللي هو فطري، انزين، انت بتضربه هو وهو بيضربك انت، ما حد فيكم بيضرب نفسه. I'm hoping. انزين، ما حد فيكم بيضرب نفسه، تضرب الثاني، ففي الاتجاه المعاكس. Every action there is an equal or opposite reaction. It has to be in opposite directions. It has to be on شو اسمه it has to be in opposite directions. It has to be equal. Okay, and there needs to be contacts. There need to be touch. Okay. وانا اعطي هذا المثال لسبب جدا مهم. لما قلت لك انت بتضربه هو بيضربك، انزين، this is a very important thing. Your punch is on the other guy and the other guy punch is on you. Okay, why am I saying this? Because it is important to realize in Newton's third law, and this is a very confusing point, and many times not only students, even instructors and people and people who have been doing this for a long time forget this. It is important to realize that these forces act on different things and not on the same thing. Okay, so for example, okay, in the example before, okay, we had two people pushing a box، صح؟ قلنا واحد 100 واحد سالب 100، وبالتالي the net force is 0 والبوكس ما يتحرك، صح؟ طيب جميل جدا. يوم انا اجي امشي، انزين، يوم انا اجي امشي رجولي تضغط على الارض، تدفر الارض، وبالمقابل الارض تدفر رجولي، opposite direction same magnitude. طيب why is it not zero؟ على حسب ما قلنا نحن قبل شويه مع البوكس، مفروض they are opposite in direction same magnitude، مفروض يكون زيرو. ليش ما زيرو؟
ما نفس الجسم.
لانه ما نفس الجسم. اوكي، دائما تذكروا تضرب غيرك ما تضرب نفسك. انزين، I am putting FPG F of the sorry, I am putting FGP my foot on the ground, so I am exerting the force on the ground. FPG, which is opposite in direction and the same magnitude, is the ground pushing on me. So one force is on the ground, the other force is on my foot. They're not on one object. Okay, and that is an extremely important distinction. Okay, that is an extremely important distinction. Now we have some sample forces in this, which we will do in the next lecture. It's 120. I will end this lecture by giving you this question. Please copy it on a piece of paper or take a screenshot or a photo or something and think about it, because we will start next lecture with this. A 20-ton truck moving left hits a 0.1 gram butterfly. Which of the following is true? The truck's force on the butterfly is larger than the force of the butterfly on the truck. The truck's force on the butterfly is smaller than the force of the butterfly on the truck, or both forces are equal. Remember, F equals ma. Okay, so we're not going to answer this today. We're going to start this at the beginning of next lecture, okay? And whatever your answer is, A, B, or C, be prepared in your head at least with a reason. Why do you think that is? Okay, and we will start the next lecture probably with a quick, breakout rooms to start discussing about this and then continue with it. Tamam?
Okay, Doctor.
With this, we end today's lecture. Alhamdulillahi Rabbil Alameen.